Theory behind graphic. Really hoping the system. Okay. So first things first. F of x equals a to the x is going to be our parent function. Our parent function. We need to understand a couple of things here, okay? This a, we call the base. This x has two words. I can call it the exponent. I could also call it a superscript. Let me write that again, because that was terrible. Okay, superscript. Superscript means above what is already written. And this, of course, is my function. Now, I only need 2 points to find the equation of an exponential function, much like we need 2 points to find the equation of a line. So what I'm going to do is I'm going to make a little xy table. I have my x and I have my f of x. And I want to plug in 2 very easy values in order to find the graph of this equation. First off, if I plug in 0, what is anything to the 0th power? 1. So 0, 1 is on every single parent function's graph for exponentials, no matter what the value of a is. If it's 2 to the x, 0, 1 is still on there. If it's 7 to the x, 0, 1 is still on there. Now, if I plug in 1, what will I get? I'll get a. Okay. So what this means is if I have maybe like f of x equals 2 to the x as my parent function, 1, 2 will be on the graph. If I have 3 to the x, 1, 3. If I have 1/2 to the x, it'll be 1, 1/2. Okay? So if you know the parent function, can you find these points real easy? Yeah, without any work. So I know that the 2 points, 0, 1, and 1, a, are on my function. Now, with exponential functions, I also have something called asymptotes. And asymptotes are lines that a function normally gets very close to and never touches. So if for an exponential function, that asymptote is going to be located right here on the x-axis. So again, this is an asymptote. I always recommend you draw the asymptote first, every single time, because that gives you guidelines with respect to what line it gets really close to. And now I can graph my 2 points. So I have 0, 1. I have 1, a, and a is just some arbitrary value. And my exponential function looks like this. So that's every single parent function for exponential graph theory. Questions so far? Good. Fairly simple, honestly. Exponentials aren't that bad. All right, so let's get to the next point. Next part, sorry. Let's say I have this equation, f of x equals a times little a to the x minus h power plus okay, this is what I like to call general form. As a reminder of transformations, what does the h do to a graph? Left or right or up and down? Moves it left and right. Yeah? So this h value moves left and right. It's the opposite of what you think. If this is a +2, it moves it left 2. If it's a -4, it moves it right 4. What does the k do? K moves it up and down. Perfect. And what does this do? Vertical stretch or vertical shrink, vertical compression. Okay? So now what I'm going to do is teach this to you first in context of your actual problems, because I don't want to give you information you really don't need. Okay? So let's say that I have the following type of problem. Let's say that at time 0, my population is 200. So this is time, this is population. Let's say that's like when my country was conceived. So for the United States, that's weird way to say it. For the United States, that would represent like 1776, right? The year that our country became a country. That represents the population. Obviously, this is not the United States population, but I'm giving you an example. Let's say your other point that you found happened to be, I don't know, 20, comma 7,000. That means after 20 years from the time that you chose, there's 7,000 people. Okay. So what I'm going to do is teach you how to find the equation between these 2 points. So here's what we need to figure out. If I were to graph this, when we deal with population, can I ever have a negative population? No. That wouldn't make sense. And give me a sec taking here, okay? I can never have a negative population. So for the context of our project, we are not going to have a K, because my population can only decay as far as 0. So for our project, there is no K. All right. Now, when I think about how fast my population is increasing, I have to have a starting point, and I have to have a point that is not a starting point. For me, what is my starting point? Yeah, for you, it's whatever your first point is. Now, I want you to keep something in mind here, because you're going to confuse this if you don't. Your first point, I recommend every person in your group has the same reference point. So let's say the number 0 represents the year 0 AD. So if my first population happened in 1776, my first point is going to be 1776, comma, whatever my population is. So that when I combine all your points, when you combine all your points together, you have the same reference. Does that make sense? Yes, no? So let's say that, who's in your group, Charity? Okay. Let's say your points are 1975 and 1995. Yours are 1965 and 1983. His is 1937 and 1945. All of you are going to have a different starting point and a different ending point. But if you all have the same reference with respect to it being year 0 as the reference, you are going to be able to average your years and average your populations together. So your points would be the year you chose, comma, the population. Okay? All right. So I'm going to graph these 2 points first. So I have 0, comma 200. I have 20, comma 7,000. Notice how I'm graphing these. I really don't care about little slash marks. I don't. I care about you understanding what's the x value, what's the y value. So I'm going to have 2 points. I know my graph is going to look like this. Okay. Now, your starting point represents your h and your k. It represents where your value is starting. Now, on a traditional graph, this point right here would be like 0, comma 1, right? 0, comma 1. But what I want to do is make it, in this case, 0, comma 200. So that means I've amplified it how much? 200, which happens to be my starting population. Yeah. So for in this case, my A value is 200. Perfect. Now again, since this point right here is on the y-axis, have I moved it left or right any? For this example, I haven't. No. So do I have an h value? I don't have an h value, because I have not moved it left and right. I've kept it right there on the y-axis. I've just amplified it by a factor of 200. So what we're actually left with in this specific example is we have f of x equals my amplitude, which is 200, times a to the x. And we can get this without any work at all, right? That's our starting population.
Interruption.
Yeah.
Hey, can you send Eliana Watson to the front office for dismissal?
She is in Coach C's room, not mine.
Sorry, thank you.
You're welcome. Okay, now, I need to find this a value, because that tells me how fast it's growing or how fast it's decreasing. Do I have another point here that's an x and f of x? Yeah. This is another x, this is an f of x. So that means that I can plug these values in and I can solve for my amplitude. So I'm going to plug in 7,000 for my f of x. I still have my 200. I'm going to plug in 20 for my x. And I just want to find my a value. So how do I get rid of this 200? Divide. Divide. So I'm going to divide by 200. Divide by 200. Often left.
It's all right.
Yeah.
Every time today.
Every time. Alright, so I have a to the 20th power equals whatever this turns out to be. I don't know. That means it's 70 divided by 2, which is 35. Now, here's the clincher. You might forget this from Algebra 2. If I have something squared, I take the square root of both sides. If I have something cubed, I take the cubed root of both sides. If I have something to the 20th power, what do I have to do both sides? Take the 20th root. Meaning I take what I have and I split it into 20 equal parts that are multiplied together. There are two ways to do it. Here's the easiest way. I'm going to raise each side to the 1 over 20th power. Here's why. If I have 20 times 1 over 20, what happens? Cancel. They're reciprocal. So I'm left with a. And my a turns out to be whatever this is. I would turn it into 35 raised to the parenthesis 1 divided by 20th power parenthesis in my calculator. So I can find the answer. Right? That's how you would take the 20th root of something in your calculator. So, if I do that, let's get a number. Let's do a number. No, this is not that bad.
Saying someone who has a master's.
Yeah?
We go.
Alright, let's see here. 35. So I get like 1.19-ish. So notice, there really isn't too much math going on here. There's this equation where this represents like my starting value in this case. I get the a by itself, and I get my a value. So when I write my final equation, it's going to be f of x equals my big A, which is 200, times my little a, which is 1.19, the x power. So in essence, what this means is my population is growing 19% after every year. So it means I take the full population, which is like multiplying by 1, and I add 19%, which is like the 0.19 piece. Again, if you need additional workshops on this, this is fine. I'm just giving you the basics right now. Okay. Now here is where this comes into play. For your group regression model, I'm going to use this group as an example. You are going to have an A model, or an A value. You are going to have an A value. You are going to have an A value. They're probably not all going to be the same. I need that A value to find a regression model. So what are you going to do with your A value, and your A value? You're going to average them. You're going to average them. Once you average them, all you need to do is take the first date's population which would be like your amplitude, and then you have your equation. So for your group regression, step 1 is you average your A values. Step 2, you find your amplitude. 3, you write the equation. And what should happen, what I'm looking for, is when you create an electronic graph of each person's model, this regression model should kind of fit nicely in between all of them. It should be an average of them all. Does that make sense?
Yep.
Cool. Excellent, excellent, excellent. Fantastic. Okay. So here's what I want you to do. Prior to getting to those assignments that I have linked on the agenda, I want you to try this out for your populations. Capiche?
Yep.
Posh. All right. Cool, 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 cool. Excellent.